G'day team, welcome back to another video. So today we're going to be starting to look at linear relationships and direct proportionality. So two variables, typically x and y, but they can be any variables, okay? They are linearly related if the graph connecting them is a straight line. So super simple to work out if two variables are linearly related. Just see if their graph is a straight line. So here's 4 examples. So A, that is a straight line, so the two variables that make this graph are linearly related. B has a nice curve to it, so this is not a straight line, so therefore the variables in graph B are not linearly related, and C and D are both straight lines, so they are linearly related. Really easy, quick test to do. Now, from a table, we can see if they are linearly related because each step in each variable is the same. So we're plus 1, plus 1, plus 1. And here we've got plus 5, plus 5, plus 5. So each step that the x variable makes will result in the same happening for the y. So every time we go across one x, we go up 5y. So let's just show this graphically. So let's graph these points. So 0, 10, 1, 15, 2, 20, and 3, 25. And we draw a line through the points. That is a straight line, so these are definitely linearly related. Now, the second part of this sort of video is looking at direct proportionality. So, two variables are directly proportional if multiplying one by some number causes the other to be multiplied by the same number. So we get this y equals mx result where m is the slope of our line or gradient. Another condition that we get is that our line will pass through the origin at 0, 0. So another little test that we can do. So using those two, so we need a straight line and we need to go through 0, 0. Graph A is directly proportional because it's the two conditions. Graph B is not because it doesn't go through the origin. Graph C is not because it doesn't go through the origin. And graph D is because it's linearly related and it goes through the origin. All right, again, let's have a look at what happens when we look at a table. So every time we go up one step of, so each step of x has the same multiplication. So 0, if we multiply by 2, gives 0. 1 multiplied by 2 gives 2. 2 multiplied by 2 gives 4. 3 multiplied by 2 gives 6. Okay, so these are directly proportional. But let's graph it again. So we've got 0, 0, 1, 2, 2, 4, 3, 6. And we just put a line nice and straight, there we go, through those points. All right, and we can see that it goes through the origin and it's a straight line, so it's directly proportional. Now, one last key skill is finding an equation of our line from a graph. And our linear equations come in the form y equals mx plus c, okay? So we need to find this m, which if you remember from before is our slope or gradient, and c is our y-intercept. So we have a graph here. So we have x1 and y1 and x2 and y2. Now these are actually the values 0, 10, and 15 and 1. Now to find the slope, so we've got let's rewrite our equation, y equals mx plus c. We will start by finding our slope. Now m is equal to y2 take y1, so the change in y divided by the change in x, so rise over run. Now y2 we said was, I got these around the wrong way, sorry, so 115. So we said our y2 was 15, our y1 is 10, x2 is 1, and x1 is 0. 15 take away 10 is 5, 1 take away 0 is 1, so we're left with 5. So let's substitute that into our equation. So m is 5 plus c. Now, looking at our graph, we can quite clearly see that it does go through 10, but if it doesn't have a scale, where it's a fraction, it's a bit harder to read, we can use a method of substitution. So we choose another point on our line. So let's choose the point 1 and 15. So x equals 1, y equals 15. And we substitute those values into our equation. So 15, 5 times by 1 plus c. Now 5 times by 1 is just 5. And to get rid of positive 5, we subtract 5 from both sides. So 10 is equal to c. So let's substitute that in. Y equals 5x plus c, and plus 10, we found c. All right, and now we have the equation of our line. All right, hopefully those few skills and definitions will help carry you forward, and we'll see you in the next one.